So in this video, we're going to go through section 11.2, which is all about odds. So if you've ever looked at any type of sporting event or some type of gambling, you're going to constantly hear odds against this particular thing happening. So you go to place a bet on a specific team, or maybe it's an MMA fight, there are going to be odds for this specific player winning. So we're going to go through how to actually calculate that today. So we're going to start with the odds against an event occurring. So what this is a ratio. It's going to be the probability the event fails to occur divided by the probability the event will occur. So it's a nice simple formula. The odds against the event are the probability the event fails divided by the probability that it occurs. So a simpler way to think about that is the probability of a failure divided by the probability of success. Okay? So we just need to be able to calculate these two things given whatever specific event we're looking at. So let's start with a standard die. We want to determine the odds against the event occurring. So the event we're going to look at is the odds against rolling a 4 on one roll of a fair die, so a standard die. So we need to figure out two things. The event occurring is rolling a 4, so we need the probability of rolling a 4, and we need the probability of failing to roll a 4. And it's a standard die, so the probability of rolling a 4 is 1 over 6. And the probability of that not happening is 1 minus the probability of it happening. So another way you can think of this from our last section is there's one way out of 6 to roll a 4. There are 5 ways to not roll a 4. So these are our two probability of success and our probability of failure. So this one here is our success. And this here is our failure. Okay. So we just need to take the ratio of this and then we're going to simplify it down. So the odds against rolling a 4 are the probability of our failure, which is this one over here, over the probability of our success. So the probability of failure is 5 over 6. Probability of success is 1 over 6. So remember here, when you're dividing two fractions, it's the same thing as multiplying by the reciprocal. And then nice stuff happens because they were both out of 6 for our probabilities. Those cancel, and you get just 5 divided by 1. So way we actually have to write this are the odds against rolling a 5 are 5 to 1. So these are the odds against rolling a 4. Okay? So you can say it as 5 to 1, like right here, or you can write it in this form with a 5 semicolon 1. Both of those tell you exactly the same thing. Okay? So let's try another example. Let's look at the odds against selecting a king from a standard deck of cards. So we need two things again. We need the probability of selecting a king, and then we need the probability of failing, so not a king. So remember there are 4 cards out of 52 that are kings. So we can simplify that. There's a 1 in 13 chance of you selecting a king. So this here is our success. The probability of not a king is 1 minus that. So we get 1 minus 1 over 13, which is 12 over 13. So this is our probability of failure. So we just need to look at the probability of failure divided by the probability of success. So the odds against selecting a king are failure over success. So here's failure, and here is success. Okay? And same thing again, when you go to take the division of those fractions, you multiply by the reciprocal of the denominator. So the reciprocal is right there. And because both of them are out of 13, the 13's cancel, and you're left with 12 divided by 1. So what we would say the odds against selecting a king are 12 to 1. So you have pretty good odds against selecting a king. So one thing you want to kind of notice each time you're doing this, when you're looking at the probability of success and probability of failure, you're looking at the probability it occurs and it does not. So those are going to sum to 1 every single time. And they're always going to have exactly the same denominator. So both of them have the 13. The other thing you want to look at is when you take the 12 and add it to 1, it's exactly the denominator you had. Same thing if we go back up here. You had a 5 and you had a 1. These two together add to the 6, which is the denominator. So that's going to happen every single time because these two events are going to take up the entire space. You're going to get a king or you don't get a king. You're going to roll a 4 or you're not going to roll a 4. So it's got to take every single possibility into account. Okay? All right. So now let's go ahead. The nice thing is if you want odds in favor, you're just going to flip that fraction. So the odds in favor of an event occurring are going to be the probability of success divided by the probability of failure. So it's just the flip of this. So if you look at the prior two examples, if we scroll back up, the odds against rolling a 5 are 5 to 1. The odds in favor of rolling a 5 are 1 over 5. So there's a 1 in 5 chance. If you want the odds in favor of selecting a king, it's just going to be the reverse of that. So it's a 1 to 12 chance in favor of getting a king. Okay. So when you look at any type of sports betting, you're going to be able to kind of recognize, is this a good chance it's going to happen? Is it a bad chance it's going to happen? The worse the chance, the better the payout, but there's a gamble in it. Okay. So we've done pretty much at this point just examples dealing with cards and dealing with rolling a die. So we're going to change it up a little bit. We're going to consider selecting a marble from a box. So we're going to pick one marble at random. There's going to be 12 blue marbles. Let's highlight those in blue. And then there's going to be 16 red marbles. So first thing we want to do is we want to determine the odds against selecting a red marble. First thing we've got to do, we've got to find the probability of getting a red. So what we need to do, there are 16 red marbles. So that's our possible chance. These are the events that are favorable to our outcome. And then in the bottom, we need to look at our total possible outcomes. So you have 16 red and you have 12 blue. So in total, you have 28 marbles you can pick from. So 16 out of the 28 are going to be successful for us. And both of those are divisible by 4. So we take the top divided by 4, bottom divided by 4. And the simplest form we have for success is 4 out of 7. Okay. Now we need the probability of not getting a red. So remember, it's 1 minus the probability of selecting red. So 1 minus 4 over 7. So we have a 3 in 7 chance of there being failure. So if you think of this, because there's just 2 colors, the probability of failure is really just the probability of you getting a blue marble, okay? Because you're going to pick one of these 2, so failure would be you pick a blue. So our odds against selecting a red marble are going to be the reciprocal of these 2. So the probability of success divided by the probability of failure. So success is a red marble up top, failure is a blue marble on the bottom. Same thing again, when you're dividing by 4 over 7, it's the same thing as multiplying by the reciprocal, so the 7's cancel, and you get 3 over 4. So the odds against selecting a red are 3 to 4. Okay? And same thing you want to recognize here is this 3 and the 4 add up to that 7. If you didn't reduce it, then you'd still see those things would add up to 28, because your probability of not a red would be 12 out of 28. Now if we look at the odds in favor of selecting a blue, it's going to be pretty similar, because the odds against selecting a red mean you're going to be selecting a blue. So let's see what our success is here. So we need to look at the probability of blue. So there are 12 blue marbles, and in total there's 12 blue plus a 16 red. So you have a 12 in 28 chance of getting a blue marble. And again, we want to simplify. So divide both by 4, and you have a 3 in 7 chance of it being a success. So this event would be successful when we get a blue marble. Now we need to look at the probability of not a blue. So we take 1 minus the probability of blue. And so we have a 4 in 7 chance of this event being a failure. So what that means is, again, you're selecting a red marble. That's how you would fail it. So the odds in favor of selecting a blue are the success divided by failure. So here's our success. Our failure is selecting the red. Same thing happens when you divide by 4 over 7. You multiply by the reciprocal. So you have a 3 to 4 chance, or 3 to 4 odds in favor of selecting a blue marble. Okay? So odds in favor of selecting a blue are 3 to 4, which is the same thing as the odds against selecting a red. So these two kind of go hand in hand, right? So now with these have all been theoretical probabilities that we've been able to calculate, because everything is equally likely. You've got a mixed box, you're going to pull one out from random, you've got the same chance of selecting this specific marble each time. When you start to get with more realistic scenarios, that's going to be that empirical probability. So we don't necessarily know that this is always going to happen, but it gives us an idea. But the odds in favor for an experiment are exactly the same thing. So we just don't like to necessarily call it a probability, but that's okay. So the odds in favor of an event happening would be that number of outcomes favorable divided by the number of outcomes unfavorable. So still the same type of idea, it's success divided by failure. Odds against would be the number of outcomes unfavorable divided by those unfavorable to whatever specific event you're occurring. Okay, so same type of idea, nothing changes, it's just a couple of definition terms. So let's look at a few more examples. We've got smartphone ownership in the country. So we've got the probability, or we've got the percentage for all these different corporations. So we want to determine the odds against the individual owning a Samsung phone. So basically, if I select one of these people at random that did the survey, what are the odds against the individual owning a Samsung phone? So if we look in our little chart, 27% of the population owns a Samsung device. Okay? So 27% owns a Samsung, and that's exactly our probability. So the probability of a Samsung is 27 out of 100. That's 27%. The probability of not a Samsung would be someone else owning any of these remaining companies. So you could absolutely add up the percentage that own Apple, the percentage that own LG, Motorola, HTC, and other, but the simplest way is you do 1 minus the probability of Samsung. So 73% didn't own a Samsung, so your probability of not is going to be 73 out of 100. So the odds against, same thing is going to happen. We're going to take the probability of failure and we're going to divide it by the probability of success. And every single time this is going to happen, the hundreds are going to cancel each other out, and the odds against owning a Samsung are 73 to 27. And the thing you want to note one last time is if you take this 73 and you add it to 27, you get that 100% because the odds in favor and the odds against better take up your entire population. Okay? So let's do one more for this specific example, but we are almost done. So we want to determine the odds in favor of owning an LG phone. So let's go back up. Now we want to look at LG. So 7% of people own an LG phone, and everyone else owned something different. So our blue would be success, the red is going to be our failure. So the probability of owning an LG phone is 7 out of 100, or 7%. And the probability of not an LG is 1 minus the 7%, or 93%. So this is 93% of people owned a different phone. So the odds in favor, we look at the reciprocal. When you divide by the 100, those are going to cancel. So the odds in favor of owning an LG are 7 to 93. Okay. So these are odds in favor of owning an LG. Now the one thing you want to notice one last time, because it's going to be important for the next example, is the 7 plus the 93 takes up the full 100%. So we are dealing with the entire population. So we're going to utilize this in this one last example. The odds in favor of me winning the lottery are 7 to 11. So we want to now kind of reverse engineer this, and we want to determine the probability that I win the lottery. So what we need to notice is the 7 and 93 added up to 100, which was our denominator. Same thing in our prior examples. The 3 and 4 added up to the 7, which was our common denominator. We go up to the previous examples as well. The 12 and 1 added up to 13, which was our denominator. And then the 5 and 1 added up to 6, which was our denominator. So this 7 to 11 better represent our entire population. So the denominator of both the probability and failure success must be the sum of these two. So this way they're able to cancel out. So our denominator in this probability has to be 18. The 7 to 11 tells us that it was 7 divided by 11. So this was the odds in favor of me winning the lottery. So that means this top one is our success. This bottom one is our failure. So they have that common denominator of 18 for them to be able to cancel out. So the probability of success will be up top. Can't fit in, there we go. and then the probability of failure is what's in the bottom. So now we can immediately say the probability of success is what's in the numerator. You have a 7 in 18 chance of actually winning the lottery. So when we finally go to the probability of me not winning the lottery, it's exactly that probability of failure, which is the bottom, which is 11 out of 18.